Hey guys, Mr. Wood back for our first video lesson for the beginning of second semester. And I was actually at school. So period 2, I was at school and now I'm at home because the internet was down at school. So for period 4, I ran home. And we're just going to continue where we are. And again, so Tuesday, Thursday, Friday, we'll do Google Meets as long as we're doing remote anyways. If that changes, which hopefully it will. Then our schedule will change, but which means Monday and Wednesday. So today should be Wednesday, January 6th. You guys should have an uploaded lesson to work on, and you guys can be working on some of those problems from the book. But important thing, of course, are jokes. And I was showing my period 4 class, and I think I've talked to you guys about this before. But one thing that I want you guys to do is to and last year was such a bummer. I've done AP Chem for many, many years now, but we always do a t-shirt. I always did that when I was a basketball coach. And of course, with what happened last spring, I never got it done, which was a bummer. But hopefully this spring we'll be in school and we can do it. So, and I always let my students design it, as long as it's hopefully PG or the worst PG-13. But anyways, here is, so this was the year 2017, 2018, and this will be our joke for the day. I left my jokes at school. But making bad chemistry jokes, let me read this right, making bad chemistry jokes because all the good ones are gone. So there you go. There's the joke for today. But you guys can start to think a little bit about that. Remember too, something I'll talk to you guys about in a couple of weeks, but in terms of getting the Princeton review, and I'm going to have you do that, but don't buy it yet. I want to get it and look at it. Princeton review for AP Chem for the 2021 test. So, okay, so back here we are. We're going to go again about 15 minutes. We're going to be reviewing dots. We're going to extend into a new way to do dots. So, okay, so pick up where we left off. Okay, so where we left off was here, where we were talking about properties of ionic compounds, and we said that they are brittle, and we explained that. Notice too on the bottom of this page, there are some problems that you guys can be working on. 31, 35, B, D, and E, 39, 45. And on Thursday, if you have questions on those, please feel free to ask me. Okay, so now here we go into new information. This is something you don't need to copy down, but just since we just talked about ionic compounds, this is just one of those for-your information things. But chemistry and medicine, ionic compounds in medicine, you can see all the different uses. One of my nieces is a nurse, and she told me once she had to memorize like 125 or 150 different medications and their different functions. So if you're thinking about someday doing something in the medical field, some of these would come into play, but you can see those. I think even with that bottom one, zinc oxide is one. I know that, and I know I think it's vitamin K. I think is things that they're saying now can help with the COVID. Okay. Now, so we talked about ionic bonding. We went into ionic bonding, and we said ionic bonding occurs when electrons are transferred from one element to another. It occurs with a metal and a non-metal. In ionic compounds, ions form. So here's a second kind of bonding, covalent bonding. So covalent bonding is when electrons are equally shared among atoms, so that as a stable electron arrangement is attained. And again, what we did in first year chem was we always just wanted to make sure that all the single dots were bonded. And that's actually, we're going to review that, but then we're going to start doing polyatomic ions and these bigger molecules, and that doesn't work for all those. And I'm going to show you today, and we'll review it on Thursday, ways that they're kind of an advanced way to do dots. And dots, because dots are going to lead into shapes, and to do dots, we gotta, or to do shapes, we gotta do dots. So But anyways, there's a couple of exceptions. But if you remember, with hydrogen, beryllium, and boron, so elements one, 3, and 4, the number of dots they have. So hydrogen has 1 dot, so it wants to pair that up, so 2. Beryllium has 2 single dots and want to pair that up, 4. Boron has 3 single dots and 6. So those rarely come up. Hydrogen does quite a bit, but the other ones do not. But most of the other elements gain stability by having 8 valence electrons. Okay, so let's just review some dots here. And again, I'm going to do this. I'm going to put it up, and then I'd encourage you maybe to stop it and go try it. So H2. So we're just going to do dots. Now we're doing dots for a compound. Okay, so I'm going to go to my board here. So H2. So what we did in first year chem then, remember, was we just paired up the single dots. So we have hydrogen with a valence electron, hydrogen with a valence electron. Oops, so you can see that. And so all they do is they pair up the single dots. And so the way we would have written it is like this, just like that. That is always the way that makes the most sense to me. Sometimes the way it's written is like that. Either way is fine. But to me, I kind of like the line because it shows the bond, okay? Okay, so I'm just going to kind of be going back and forth here. Okay, so we just did H2. Okay, NCl3. Okay, so maybe stop this and try the dots. Just review, again, the way that we did it back in first year chem. NCl3. Okay, so NCl3 looks like this. So again, I do the dots for each one. So N has 5. N has 5 valence electrons. And there's 3 chlorines. So I've got chlorine here, and chlorine has 7. And again, what we're doing here, if you remember from first year chem, is we're looking for single dots. So pair up there, there, and there. And so if I clean that up a little bit, it looks like this. And I always draw in those non-bonded, like these are called non-bonded pairs of dots. Okay, so just reviewing right now. Dots. Okay, I'm going to put up a couple here, and I'll have you guys try these. And then I'll do them as well. Okay, so H2, we just did NCl3. Okay, so try C2H6, C2H4, and HCN. So again, I give you a minute here, or pause the tape, pause the video, and see if you guys can do those. Okay, and as you guys do that, I'm going to go ahead and do those. So again, what we're doing is we're just doing the dots. Okay, so we had C2H6. So this is be an organic molecule, carbon being an organic compound. So I've got carbon, which has 4 single dots, and then another carbon, which has 4 single dots. And then I have 6 hydrogens. So the hydrogens I know have 1 single dot. So I'm just going to kind of evenly spread those out. So it looks kind of confusing. And then I'm just going to pair up single dots. So here, 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 and then here. And so if I clean that up a little bit, it looks like this. Okay, C2H6. Okay, the next one was C2H4. It's a C2H4, so I got 2 carbons. And And then I got 4 H's. So again, I'm going to kind of evenly spread them out. Okay, and then I'm going to start connecting single dots. And I get there, and then at first year chem, hopefully you remember, okay, well, what do? We still have both carbons, we both have a single dot. So what we're going to do then is we're going to pair those up, and that's going to be a double bond. So this is going to look like this. So there's C2H4 with a double bond in it. Okay, the next one we got is HCN. So let me go down here. Of course, if I was in class, I'd go, could you name that? That's an acid without oxygen, hydrocyanic acid. So I've got H, we're doing dots now with 1 dot. I've got carbon with 4, and then I got nitrogen with 5. So I'm going to put the pair there. So pair up singles, so pair up there, there, and there. So if I clean that up, then I get H with carbon triple bonded to nitrogen like that. Okay, unfortunately, they're not all like that. It gets to be a little bit trickier than that. And so if we have this one, and this is the kind that we're, of course, being now in AP Chem, so now we're going into new territory. Okay, so we just did those. So how about this one? NO3 -1. So let's talk about this. And I want to show you this new way to do dots, and then that's where we'll pick up on Thursday. So nitrate ion, NO3 -1. So let's go back and try and do it the way that I taught you, in the way, I know Mr. Conyers has a real ingenious way to teach this, and Mr. Hodis, but if we go back, NO3 -1. And so if I do the dots, I've got N with 5. I've got oxygen with 6. And if I start pairing up single dots, I go here, 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 and then here. And it ends up being kind of a mess. And so when we have these polyatomic ions, and I guess the -1 means I added 1. I'm going to show you this way, and this is the way that I want us to do dots. Really, if it's a simple way, especially if it's an element from the first row or the second row on the periodic table, we can do this. But the way we're going to have to do some of the ones we're going to have to do later on in this chapter, I want to show you how to do dots with this. And this is actually something in the notes. Oops, I want to go back here. Okay, so I'm going to go forward in my notes. I'm kind of jumping around. I'm going to go down to this slide here. Okay, so this will be where we're going to close. But anyways, let me just put this up, and I've kind of changed this slide a little bit. But a major shortcoming of Lewis structures is their inability to predict the molecular geometry. Molecular geometry means shape. And so, and what the dots are going to determine the shape. And then many properties are going to, such as melting point, boiling point, density, types of reactions can be estimated when the geometry, the shape of the molecule is known. Okay, so knowing the shape is important. And to know the shape, we got to know dots. So here again, I've kind of changed this a little bit. Okay, so again, I'm going to just read this, and of course you could stop this, but valence shell electron pair repulsion, the Vesper theory, which you don't have to memorize, but what it says is that electrons pairs repel each other whether they are in chemical bonds or unshared. So in other words, remember, opposites attract, likes repel. Well, electrons are negatively charged, so they're going to repel each other. So they're going to want to get as far away from each other as they possibly can. And so that's going to be kind of the idea, the philosophy, the idea behind this. Electron pairs assume orientation about an atom to minimize repulsions. So again, the shapes that are taken are is when these bonds, these electrons get as far away from each other as they can. Double and triple bonds are treated as a single representative cloud of electrons. Kind of the core thing we're going to get to in this chapter, kind of connecting chapters 8 and 9, are these things called electron domains. An electron domain is a single bond, double bond, or triple bond. That's something we'll talk about later. But steps in writing electron dot structures if matching up the dots does not work, which is going to be a lot of the ones we do. And I'll do one example, and this is where we'll pick up on Thursday. But number one, determine the total number of valence electrons. So count the valence electrons. The central atom, number two, the central atom is always written first in the formula. So whatever element's first, that's the central, the middle atom. Number three, put the other elements around the central atom and fill each atom's octet. So in other words, fill the outer shell for all the atoms. And then what will happen is extra electrons, or if electrons need to be removed, they will come off or added to the central atom. Okay, so all that being said, let me so let me just go back to this one now, using that, and this is where we'll pick up because I know there will be questions on this. So here is now the advanced way to do dots. So we have polyatomic ions and these bigger molecules. But if I've got NO3, -1, so step number one is to count the valence electrons. So nitrogen has 5, oxygen has 6. 6 times 3 is 18. And then -1 is 1. So there's 24 total valence electrons. So the first thing I do is I count the valence electrons. Okay, now I do the structure with the element written first in the center. So I'm going to put N in the middle, and I'm going to put the other elements around it. So I count the valence electrons. The element that goes first goes in the middle, and the other elements go around it. And now I'm going to fill everything's octet, which means everything's going to get 8. So it's going to go like this. So I filled everything's outer shell. And now I'm going to count up. I get 24 valence electrons. Let's see how many we use. 2, 4, 6, that's 8. 10, 12, 14, 16, 18, 20, 22, 24, 26. So I have 26 dots, but I'm only allowed 24. And then what I said is, if that is the case, then off the central atom, nitrogen, is where either we add or remove. So I got to take 2 away. So I'm going to take those 2 away because I can only get 24 dots. But if we stop there, nitrogen now is not stable. It does not have, it's lacking 2 electrons. So what happens is any of these oxygens sees this and has the generous spirit and says, listen, I'm going to donate both of these electrons. And so what this ends up looking like then is like this. There's a double bond. And that is the correct way to do nitrate. Now, if you're following me, and again, we'll pick up with this on Thursday, you could go, well, why, Mr. Wood, did you choose the oxygen on the right? You're right. I could have chosen the one on the bottom. And so what this could have looked like is the double bond could have been there. Or you could say, well, why don't you choose the one on the right? Well, you could have. You're right. You could have done that. And this is what's called resonance. When you can do a dot structure in more than one way, that is called resonance. And I know that that's confusing, and we're going to do a number more of dots before, in class on Thursday and in this chapter. So, okay, I'm going to stop there. Hey, I will see you guys tomorrow. We're dots mania now. Bye.